All right, we're live. So good evening, everyone. Good morning in the west coast of the US. Richard, thanks for joining us for this hangout. We're going to be talking about downtime, on-call, systems administration, and kind of the people aspects around running large-scale infrastructure. So we'll just do a quick intro, and then we'll get into the topics. So my name is David Mytton. I'm the founder of Server Density. We do server and web availability monitoring. We have around 100, 150 servers, mixture of VMs and bare metal across 2 data centers in the US. We process around 200 terabytes of incoming data a month using Python, Nginx, and MongoDB. Charlie?
Hi, my name's Charlie Allom. I'm a network engineer at Yelp. I'm sure a lot of you have heard of Yelp, and I don't really need to introduce what we do, but I'm part of a large team of operations SREs. There's about 20 of us spread across the globe. And yeah, thanks for inviting us, David.
And Brian?
Hi, my name's Brian Trump. I'm a site reliability engineer at Yelp with Charlie on the other side of the team. It's nice to be here. Thank you, David.
All right, so we've got a few topics that we're going to go through. It's going to be lightly structured and that we know what we're going to be talking about, and I've got a few topics to go through, but it's more of a discussion. I'm going to talk about how we do things at Server Density and how the Yelp guys do things, and then we'll kind of contrast and discuss different options. So I suppose the context for all of this discussion is downtime and how likely that is. I think the stats I were using when I was presenting this as a talk a couple of weeks ago in London was comparing the amount of money that's spent by the big cloud providers. So the likes of Microsoft, Google, and Amazon are spending billions of dollars each quarter, and they're still having outages. These outages are affecting their consumer services, but also kind of the internal services that developers might consume. Charlie and Brian, I don't know what you can talk about how you view downtime and the likelihood of it, and what kind of failures you see on your infrastructure.
Sure. I mean, failure happens all the time, and as you get larger and larger, you end up with lots of different architectures, and you also end up with lots of different legacy versions of architectures. And I think any organization that tells you that they run a completely snappy environment that's all the plan is really kind of not telling the whole picture. So you've got to be honest with yourself about what's out there, and also how to structure infrastructure that is going to allow things to fail. Because in networking, certainly, things fail all the time. And particularly when it's written in software, because it's written by humans, and software can be pretty problematic. So yeah, we think about failure as a constant, and also that's something that shouldn't necessarily wake us up and make us angry day to day. You know?
Yeah, and it seems that from the very beginning, the cloud environments have been supposed to be designed so that you assume failure into your infrastructure, as opposed to perhaps the older style unmanaged and managed hosting where you're buying a dedicated server and you might expect it to be very high reliability. Do you think people approach it in that way, or what I've seen is that people tend to spin up a server and they expect it to stay running for years on AWS, for example?
I think you only need to look at the companies that publicly complained when Amazon had to reboot a lot of machines a few weeks ago. And the companies that complained publicly were basically saying, we took all the warnings on board about failure being constant and always ever present, and we treated this system as a rack of machines that we knew that there was always going to be power on. So we had yeah, I thought that was interesting, that it gave you a little bit of an insight if you saw people talking about it, about how people view this and how actually realistic it is to run a large deployment that is on Amazon hardware or whatever other cloud provider, and how hard it is for people to wrap their head around that concept. That you've got to kind of start thinking about failure from the first day when you're drawing on a whiteboard.
So, Brian, what's your approach on how you would approach designing for these kind of failures, and when you're approaching site reliability, kind of what do you think the considerations are?
I like failure. I like things that fail in interesting and horrifying ways. And I think that there's an emerging culture amongst larger organizations where they embrace failure instead of living fear of it. PagerDuty does a really cool thing with Failure Fridays where they shoot things in the head in various ways. It's similar to like Netflix, Chaos Monkey, and Gorilla and Kong. They create failure in the hopes that they can learn from it before it actually happens, the inevitability of it happening. And I think that's a really good approach.
Ryan, do you think only large organizations are able to really embrace failure in those ways, like PagerDuty and Netflix, or do you think a smaller organization could also, with a limited kind of financial budget, do you think a small organization could embrace that?
I think that's difficult. Working at both larger and smaller places, there's always budget concerns. It's a hard sell to say, well, we need level N of redundancy, but it's going to cost this much. It's hard to justify.
Mm-hmm. I think it can be hard to quantify what the value of having uptime is versus how much it costs you to be down. I think perhaps if you're an e-commerce website, it's easier to say, well, we're not getting as many orders because the site is slow, or if you're down, then you can calculate how many orders you're losing. But perhaps as a web app or a mobile app, when something is failing, there's no direct monetary value on it, so it can be more difficult to quantify.
Yes, I mean, I think always my argument when I'm talking to the kind of management boards is not really about the quantification of like downtime equals revenue, but downtime equals kind of perceived, reliability of the brand. It's harming the brand, really. And that's when I find if you're in a small company and having to push your idea up, and some of these companies work like that, you can say, how about the brand? Because surely that's what we're all trying to work towards, to create something where people just instantly click and say, buy.
Yeah, and we've certainly found that performance in the app as well is all related to this, and downtime doesn't necessarily mean that you're just up or down. It could also mean that the calls are timing out, or requests are very slow. And it's not as obvious when that isn't the case unless you have the right metrics in place, of course, and customers tend to become very dissatisfied with that and then churn out of the product rather than perhaps it just being like a red alert thing, everything is down. It's much more of a subtle problem.
Absolutely.
Do you think the introduction of things like the live migration technology on Google Compute Engine, or perhaps the more abstracted layer of infrastructure for something like Mesos or running on containers, means that downtime will become abstracted out from infrastructure, just because the underlying system will move things around?
I'm a cynic, and I think as things move on, we all have these dreams of saying, this new thing is really going to solve our issues. Like in networking, people have moved away from layer 2 networks into layer 3 networks, and that's because the technology underlying it has allowed us to do that. You can have a switch that does routing, and you can have software on servers that does layer 3 routing. It's the technology that allows people to think, wow, this is really going away. But it's software. You're creating failure modes that you've never seen before. So my feeling is that no, there's no golden bullet to this. But other people, I'm happy for other people to prove me wrong.
All right, so let's move on to a bit more practical topics around on-call and how each of us does things like rotations, escalations, and availability. So coming at it from a very small organization, Server Density is 12 people, 10 engineers, and 10 technical people. And the way that we handle it is by having one person, what we call the primary, who's going to receive alerts, and another person as a secondary, so that if the primary is unavailable or needs immediate help, then it escalates to them. And we rotate through our team so that pretty much all the engineers take a turn at being that primary person, but it's once every 9 weeks or thereabouts, which allows people to cycle in and out and not be on call all the time. How do you approach it with a significantly larger team that's just dedicated for this?
In a different way than we did when I started. When we started, I think we were far fewer people, 5 or 6, I think it was. And the approach was to do a once-a-week on-call rotation with the primary and secondary, of which the nomenclature didn't really apply. We would both receive the alerts at the same time. And you have that kind of baseball outfielder scenario where both people are going for the ball at the same time. You don't really know who's calling it. Since we've made lots of adjustments, lots of changes, in an attempt to reduce kind of the stress of a week of being on call, it'll wear you out, when your pager's going off for a solid week. We implemented a one-day rotation that actually escalates primary to secondary. And with a team of the size of ours, that puts us on call roughly about once every week and a half. And what we found is that the fatigue of being on call, even though the duration is shorter, the frequency is more. And that eats away at you in a different kind of way. Mm-hmm. Kind of chips away at you more than completely exhausting you after a week. So we're now trying a 2-day on, 2-day off sort of thing as secondary and primary, which is working out pretty well for us. But it's really nice to have that dedicated resource of on-call people, and especially having people in different time zones.
And with so many people, I find it really useful. It's a real pleasure, particularly in our team, where people are very friendly and people say, you know what, I want to, this weekend I want to go climbing or whatever it is, and you're able to trade things. Whereas in a smaller team, I know in a team where I was working with 4 people, you couldn't do that. 2 people would be out of town. One guy would never want to take the shift. It was your go. That was it. I feel like having a good culture of people being able to say, yeah, I'll trade you. I want to visit my family next weekend. I'll trade you my days. That really helps as well.
Yeah, I think that's incredibly important. We have kind of a relaxed nonchalance about the pager and who has it. We're supportive of each other and have facilitated with tools too. We can, for example, we have a Qbot that runs on an IRC channel that we can say, hey, pager me for 2 hours, and we'll take a pager from someone while they get a haircut or something.
Absolutely. In London, it's useful in the tube. I have colleagues that take on-call for me while I'm underground, just for an hour.
Yeah, that's one of the key things, is thinking about availability and where people are, how quickly they can get to a computer to respond to alerts, and what their network connectivity is going to be like. Even if you could respond to an alert whilst you're on the tube, you'd be on 3G, probably, maybe 4G if you're in the right area, but probably 3G or worse, and trying to SSH in and trying to fix problems with that kind of connectivity is an issue.
Yeah, and that's where escalation becomes a really important point, to know that you are on call and you are empowered to escalate under certain situations. And that may be, a place where I thought I could get back to a laptop in 5 minutes, but I suddenly can't because X, Y, Z. And you're empowered to wake someone up or to call in someone else. We have a great kind of process that it's very relaxed. But the things I like about our process is that they kind of fit on an A5 sheet of paper, and you can read them once and you can get them and understand how to apply it to yourself. But maybe I'll talk about that a little more once we get to actual hand-running incidents.
One of the things that we found when we had a smaller team was that when someone took an incident in the middle of the night, then it would perhaps obviously affect their productivity the next day. And when you're in such a small team, when engineers are working on building features and helping customers, that has quite an impact on the roadmap and what you're able to do the next day. So we took a policy of having off-call after incidents. So if you're woken up in the middle of the night and you have to deal with something, then wherever possible, the next day you don't have to take on call for 24 hours, and often you can come in late or not do as much work, or be expected to do as much work as if you had like a normal day.
I've heard other companies that are based in London do an off-call thing similar, but actually the on-call person is never even expected to come in. So the on-call, you do on-call in the evening and during the day, and I assume this company has some pretty serious alerts going on, but during the day you get to do things like sleep in, do your washing, all the things you couldn't do in those evenings. That seems quite extreme, but the people I've spoken to about that seemed really happy with it, that they were able to do their own stuff. But in a small team, that really kind of takes a lot of, it's good to have people around in the office and buy them a beer and say, geez, Jim, that really sucked.
It's such a good point about the number of alerts that you get. So you would expect that everyone's trying to reduce it down to 0 alerts. Is that the case?
Yeah, that'd be great. I think that's alert white noise is hard to deal with. It's hard to figure out what's important to alert on and what's not. I hold the belief that you should really only ever alert on something that's user facing, or an impending doom of some sort. If you know the time constraints of it, you can ticket it. You can settle it in the future. But a drop everything 5-alarm fire, I can only do about 2 or 3 good pages a day where I've rushed to my computer before fatigue. And I think reducing white noise has a lot to do with alerting on the effect and not the cause, and then aggregating the causes into the effect alert so that you have context to deal with that.
That's the holy grail of alerting, I think, is to say what is, how do we link the effect with the cause and make a computer give you a sensible output. I think it would be a fallacy to say that that's what we do at Yelp. We struggle, like everybody does, trying to cut down on the white noise. And something that we're definitely doing at the moment is, an alert comes in, you're on call, you're empowered to ask the real questions of the people who wrote the code or the people that own the code base or whatever it is, and say, is this actionable? If it's not actionable, it's no longer a paging alert. It's an email. It's an email that creates a ticket automatically of a high priority, whatever your thing is. If I can't action it on the tube or wherever, at my desk, with 9 hours sleep, then I don't want it on my phone. It has to be actionable, I think.
Yeah, definitely. It's got to be something that requires human intervention as well. Maybe the first time you get an alert, it's something you have to fix manually, but ideally you then script it to fix itself if possible next time. You don't want to be getting alerts that you just have to run a command to fix it, or if you just pause the alert for 10 minutes, then it will solve itself.
Yep, absolutely. To give an example, we started off alerting when BGP neighbors were reset. The BGP neighbors are reset constantly. You've got lambdas all around the country. Things are pinging off and on all the time. The clever way to do that is to have end-to-end tests with something that can actually make sure it can go down multiple paths and make sure that the traffic flows both ways. And only then do you say, we've got enough effect to come back to a cause, and you can then look at that when you're at your desk and say, BGP's down on Y and Z.
All right, so I think we've covered quite a few things on the on-call side of things. Is there anything else you wanted to touch on that section, or shall we move on?
I just want to reiterate that on-call is about people helping, it may be in your job description to be on call, but also it's a human thing, and to do it out of a sense of, this is what you want to do, with the job. You want to make things better, and you're going to help out there. And I think you need to balance that with the company and make sure that the company understands that you're a human being, and if you're there helping the company, you need to be able to set your own processes. So I'm always interested in making sure that the human being is looked after there, because if you get the smartest person in the world to come in and flood them with alerts, they'll be out of there within a week.
Yeah, and one thing that I always did and continue to do is to get alerts myself as the CEO, even though I might not be on call. I wanted to know when my engineers are being woken up, because they might not be a high priority on the business side of things, but when my engineers are being woken up, then you need to increase that priority to get them fixed, because it affects the business in ways you can't necessarily measure. And so when people are being woken up, then those kind of alerts have to be fixed with priority.
Mm-hmm.
All right, and I'll just mention to the audience that if you have any questions, then you should be able to submit them. If you're logged into your Google account, you can submit them and we'll have a chance to them as we go along. All right, so next we'll talk a bit about documentation and systems and how that works. And I think in particular on-call playbooks, we can kind of link it into what we've just been discussing. How do we do this at Server Density? In the old days, we didn't really have much documentation. When it was just a small team, we all knew everything, and so we didn't need to write anything down. But as the team has grown, then nobody can really keep the whole infrastructure or what you need to do in your head, particularly if you're being woken up in the middle of the night and you need to fix something.
And it's important to keep something in your head.
Yes, exactly. Being able to find the documentation that you need, or knowing what's going on from a particular alert, that's really important. And so having the documentation there is something that we've been reviewing and trying to keep up to date over the last 12 months or so. We've ended up picking Google Docs to do that because its search is really good. It allows us to document things. It's very easy to update the documents and put in details of what's going on. I think one of the things that you mentioned, Charlie, was how you link alerts to the documentation as an immediate actionable link.
Yeah, so every alert, whether it's Nagios or Sensu, we have it all scrolling through IRC, and we use IRC heavily and for communication. And also we have multiple levels of kind of spammy IRC channels where just machines tell us what's going on constantly. And you can join certain channels which have just the critical alerts, the ones that are waking people up. If you're on call, you usually do hop on IRC, acknowledge it from the phone or however, and you can copy and paste the alert that you see on IRC directly into Google Drive. And people often create a blank document named after the alert. And Google Drive is really good at looking for document names as opposed to the content in the document. And from there, it can be a blank document and a link to a heading within a larger runbook or however it is. And I found that really useful with Google Docs. It makes searching instantaneous.
Yeah, that sounds like a good way to, especially when your team starts to grow. When people might not know what a particular alert means and what they need to do, there's only so much you can know or be trained in what to do. And having that checklist of things to go through. Have you found checklists to be particularly important for solving things?
No, I don't think so. Brian, what about you?
I think context is pretty important, and I think a checklist just provides more of that. Not quite a checklist, but something else that we do that's pretty cool. A guy on our team, Kyle, has created his tip portion of an alert, which will also be included into some of the IRC output on our paging alert channels that we kind of split screen look at a lot while we're on our computers. And it might just be a one-liner, so just being able to point out of a checklist. It'll be like, service X is down. Have you tried looking at Y to see why?
Yeah, I think we found checklists to be useful when you're going through a particular known process. So after an outage, Then we have a checklist that we go through to make sure we check all the key services to make sure that we've not missed anything. Or responding to a known particular situation like failing over from one firewall to another, perhaps.
Yes, I guess in checklists, in some cases, we have like heavily stepped scenarios for some of the more complex issues. But I always find when I'm writing checklists, I get too detailed and I wonder where to stop. You know, I wonder who my audience is sometimes.
At what point does it start looking like a bash script, you know, and then you could just codify it?
Yeah, it's, you know, I really like the Google Doc commenting feature, because if a document isn't good enough for someone, they can comment on it and they can be angry and say, what the hell is going on and why, you know, what do you mean just pseudo this, you know, like explain it. And you can have a conversation within a Google Doc and it can be resolved. It's like a mini wiki within a page. It's really nice. You know, I think I've spent years looking at all the wiki software and trying to figure out the best documentation, but as soon as I saw people using Google Docs, I just thought, why not?
How do you deal with the issue of out-of-date documentation or making sure things get updated?
I know how I would like to deal with it. That's hard. That's a really difficult thing. I think it'd be cool if documentation had an end of life, such that you could query the API for whatever it is you use for your docs, see the time it was created or last modified, and then maybe task out to someone whose job for the day is just to update documentation if you have that luxury or something. But some sort of reminder that says, hey, this is getting old, you know, possibly it's kind of crufty, you might want to look at it and update it. It's very difficult though, and you tend to only update the things that you reference quite often, and the more technologies that you adopt and the more legacy infrastructure that's left over, that's documented, the older it can have the potential it gets, and it's difficult to deal with. I think just having a real proactive attitude about it and understanding that documentation is very important for everybody to be on the same page, of course, is about the best you can do.
And I think over-communicating isn't such a bad idea. If you update documentation, send it out to your team and say, hey guys, you may all know this off I wrote, but I've made some changes to the documentation and some feedback. There's no issue for someone just to delete that email if they don't care or whatever. You know, that's their own issue. Also, you know, if I play a game because, you know, I mostly like to tinker with networks, but when I'm helping out, you know, DBA issues or whatever, inside my mind I'm always thinking, you eat the goods, you buy the goods. You know, you're going to have to, if you're going to get involved with a problem, and the documentation isn't there, then take the next hour out to write that checklist down, you know, and just trying to help people out and say this is the right way to do that. You know? I'm not sure how you get your colleagues to help out with that, because you just seem to kind of get along with that. But I've seen other organizations struggle with, I can't be bothered doing the documentation.
So in terms of what to document, is there anything that is non-obvious that you could think of that people might be missing? So, for example, some of the things that we've missed before and do now document are how to log into support contract systems, so you can get in contact with your key vendors where you need to submit tickets, or what the process is for that. Some of them require you to submit a ticket and then phone up to escalate an issue. And then also the key contacts for within the company, like how do you reach the head of engineering or someone who's responsible for a particular component?
Absolutely. I think for a small business, that is absolutely critical, because everything is done on a small time frame and a quick phone call, and to write down when you've got a new account manager and to put it in a single place is just so useful. Those interpersonal relationships between you and a vendor or whoever it is, is great, but to then come back and document and say, so-and-so gave us a discount, we went to dinner, we had a great time, and they have promised to give us a 20% discount next time we go with them. You know, something like that, to put that somewhere. It helps you managers see what you're doing, and it also helps the next person that comes along. And also, you know, it's like a diary. Hey, Jim, you promised 20%. What are you going to do about it? I've made that mistake in small businesses a lot, where I think I can keep it all in my head, and it's just impossible. It sounds like you're on the right page there, David.
Okay, so kind of linking into documentation as the systems around handling downtime incidents. So you mentioned you use IRC quite a lot. I assume that's hosted outside of your primary infrastructure?
Yeah, I think you've really got to think about where your communication channels are based, and make sure that you're not going to take down your one sole communication system. Think about that. It's usually not that difficult to fire up an SSL, whatever it is, somewhere. And our system for dealing with incidents, like I said, is very much the person on call is empowered to really control the situation how they want. They're in charge. Oh,
We lost David here.
we did. I wonder if he'll come back.
It's all right. Another thing that I think is important when it comes to communication for incident response is having established guidelines. You know, something that everybody is on the same page with and knows to follow when things go disastrously bad. So I think something that's interesting that we're trying to implement, we don't have fully implemented yet though, is it's like a DEFCON level of when things are bad, and there's criteria for each of the different levels that has to be met and then there's a known response to those different levels. Things like halting pushes to production, or sending emails out, or changing topics in different channels to let other teams know what's going on, or then able to be done kind of programmatically based on the severity of the outage. And I think that's been really useful for us.
Yeah, I think that's where a checklist really comes into its own. When you go, oh my goodness, it's a severity 1, and you open up the document, and it's a brief document, and you have a short checklist. And the checklist says, first of all, you're in charge. Have you got someone to help you out? Who's going to do the communication? And email these 3 people or email lists. You know, that's when the checklist really comes into its own in those crisis situations, I think.
I dropped out there for a minute. Can you hear me okay now?
Yep.
Yeah, the whole operating system crashed and restarted, so that was good.
Old computers.
So I just caught the end of, you were talking about your systems and how you handle the incident when an incident starts. So the way that we handle this with Server Density is by having a room within our hit chat set up. So we have our normal rooms for different teams, but we have an operations room. And one of the rules that we use is the sterile cockpit rule. So when an incident gets triggered, then everyone who's involved in responding will switch to that room, and only essential communication is allowed. Because what you don't want is people posting up interesting YouTube videos or links and things when you're trying to solve a problem.
Absolutely. We do the same, and we do it in real life, and in MeetSpace and on IRC. You know, it's hushed voices, one person speaking. And another thing we do that's interesting is not to split the communication, not to have phone calls with someone and discuss something. Keep it on IRC. That helps everybody in the channel figure what's going on, and it's excellent for writing the postmortem afterwards. You're going to love yourself for having everybody's input. And whether it's the bots from the service saying pushes have stopped, or these keys have changed, or whatever the automatic stuff is, or just people saying my hands are off the keyboard. It's so useful.
I think that's huge. Us being very vocal in a time-stamped way. Context is extremely important, but time-stamped context is just gorgeous. We definitely have a logging infrastructure set up around the different channels that we have those types of conversations in, and they're just so great to proc for postmortems. Another thing that's really cool, I just want to brag for a second, little hubris from the programmer side of me. We have a thing that one of our engineers built, actually is a manager now, that when referencing a graph within the chat room, instead of it being the graph as it's running up until live, it'll actually take a snapshot of the graph of the time that we just referenced and include that in like a PNG URL in the tool that spits it out. So I think definitely context is very important.
Yeah, I think logging what is going on is underappreciated. I think you definitely had the right understanding there when you said you timestamp everything. So we have a single ticket within Jira that we use that gives us a unique ID for every incident, and whatever we might do, then that gets linked up to that ticket, whether it's discussion that is timestamped or commits, and any action that's taken that isn't in the chat, then it's logged on that ticket, so we know exactly who did what and when.
That's right. With a larger team, we're able to split off roles very easily, and the kind of incident handler will assign someone to be purely on communication, which means that if there are meetings or people chatting, they will actually write it into a Google document with a timestamp. That's how far down that road we go. We have someone who just documents everything, in case the context is hard to pick out of one channel.
Yeah, and this is really important for understanding your own process. So later on, during the day or when you want to review the incident, you can see what you did as a team and how you can improve that. Kind of blameless postmortems of the team and the process. But then also so you can write that postmortem and understand what happened and when.
Absolutely. Absolutely. It kind of turns incidents into some kind of manageable task. And again, it roots back into the human thing. It depressurizes, knowing that it's all going to be fine. You don't have to kind of remember everything and what's going on at the moment. You've got a log. You've got it's you can just kind of get on with the stuff. It really helps the human brain, I think.
So there's a question here that is worth answering at this particular point as we're talking about incidents, and what do you consider an incident? So we kind of touched on this earlier, but perhaps more specifically, what do you alert on? So perhaps on my side, we have a lot of end-to-end tests, so we know when the whole system is failing. And as you said, it's that kind of user-affecting problems. We know when the whole app is down. But we also alert on a few key events where it's resolved automatically, but we just want to double check things. So I think that only really happens when we do a database failover. So MongoDB is actually pretty good at failing over and recovering itself automatically. But when you're dealing with a database, then there can be kind of silent failures or data corruption. We've not ever had any of that, but we want to make sure so that we don't just leave it and run it for hours overnight when there's actually a real problem, perhaps errors in the logs that we've not picked up on.
Metrics and alerting is just critical, and I've always felt that if you can measure it, put it somewhere. It's what computers are good at. They're good at taking bits of data and shoving it somewhere, and then later on you can find it in whatever format you like. You can work on a beautiful system that puts everything into one place, and that's great. But when you're a small company, just log everything. Log all that beautiful stuff that comes out of the JVM. A lot of people just spin up Java and go, "It's working. Oh wait, I've run out of memory." Like there's so much good stuff that comes out of that. Finding it and finding out what was useful is very tricky. And that's another conversation entirely. But I feel that we follow that, Brian. Would you agree that if it's, if the computer is running an action, we log it and we have some mechanism for it to come up the stack, for it to be an alert in the future, or if someone thinks it's important enough?
I would agree, yeah. We monitor many aspects as we possibly can, and then try to, again, it's the effect and the cause side of alerting, and with effect here and a cause here, we try to be as close to effect as possible. So it's about doing clever things with every metric that we do log and alert on, to make our what we consider incidents or what we consider alerts really meaningful.
Absolutely. And when the alerts die and the metrics look better, not only do you get a better night's sleep, you get to show it and share it to the organization, and you get to say, look at us doing work where, we're having fun and we're making the thing faster or more robust or whatever it is. So we have alerting, we have postmortems on all sorts of internal tool sets. Sometimes the most important, customer can be, the developers. If they can't work, then it's a really lost day. So we don't just monitor whether you can ping the website. It's every piece of infrastructure that connects all the different business units together.
There was an interesting anecdote I read, I think, on high scalability in the last few days, and that the guys at Stripe, the payment processors, used to trigger alerts for their entire team whenever there was an error that affected a payment. So if a payment failed for some reason, they would page everybody on the company, which is interesting. Which perhaps the extreme, I think, maybe a more useful one, perhaps for payments that is important, but one thing that I think might be useful is looking at the change in something. So if you're getting just a couple of percentage of errors just normally, and then suddenly that spikes to 20% of requests are erroring, then that's really unusual in your system, and something is clearly wrong there that you want to alert on that.
That's right. And the tricky thing is measuring that change and bringing it up to the top of the stack.
Anomaly detection is hard.
Yes, definitely. It's something that I think will hopefully improve in the future, but right now you end up seeing a lot of anomalies because there's very little context in the system, and you end up having to pass them manually. Okay, I think the last thing that is worth talking about on incident handling is public status updates and how you do that to your customers. So Server Density, our customers are all engineers and sysadmins, so we'll try to be very transparent in what's going on, and we try and provide an update within as short a time as possible when there's a customer affecting outage or some kind of problem, and then update that regularly, even if there's no new information. I think what's really frustrating is if you're a user of a service and you know it's down and they've posted a status, but then it doesn't get updated for hours, and you don't know what they're doing, whether there's some kind of really massive problem behind the scenes, or they're waiting for something, or maybe they've just forgotten about it. You want to know that someone is actually working on it.
Absolutely. You don't want to be reading the Twitter timeline after an incident and seeing the angry customers. No, you want to be out there, being open. But different parts of the organization use information differently. So we have a large technical element of engineers, and then we have all sorts of other business units that understand different variations of terminology. And I've mentioned this before about communicating, and one person's role being communicating and being able to decipher who can use information depending on their role. Phones are down. It's pretty obvious. Everyone can understand that. But to the network engineers, you might say, we've got a QoS issue on an MPLS circuit. There's two totally different groups of people. But that's really important, I think. And it should be obvious, I think, if you're not tweaking.
All right, so let's move on to the last topic, which is kind of wrapping up incidents and postmortems and how those are done essentially. And there's a question that we can answer at the same time is how important they are. I think we'll all agree that they are very important.
David, do you do postmortems internally for tool sets and things like that, like I was mentioning before, like if the engineers can't work on something, would you do a postmortem even amongst 8 technical people? Or would you do it verbally, perhaps?
So we have postmortems that get sent out to the ops team and myself whenever there's a critical incident. And we then talk about what happened, what was different from the last time we may have seen this, what we did well, and what we didn't do well. And then that feeds into the engineering roadmap about things that we need to improve. And we have more of those than are made public because we try and make sure most incidents are non-affecting for customers. But where there is an issue that is affecting customers, then it usually goes into a lot more depth about what the timeline is. Because internally we can just link to the Jira ticket and you can read through what happened, and the most important thing is what we're going to do to fix it and what the engineering teams need to do. But when it's being published publicly, then we want to run through the whole process of what happened and the timeline so people can see, well, we found out about it very quickly, we did this, we did that, this is what we then had to implement, and then I think critically what you need to do in the future to fix it, because that's what customers want to know. Often they'll be, I'm not happy, but they'll be understanding when you have an outage, but they want to make sure that it's not going to happen again. And so they want to try and understand what you're going to do to prevent it or what needs to happen in the future.
And your customers are everything from highly technically savvy to not so much. How do you word those public postmortems?
So we do include the technical detail, but it's written in a way that it's almost like telling the story of what happened. And where there's something that's very technical, then it can be explained if possible. But we do have a bit of a luxury in that we can assume some baseline level of knowledge. And is that different for when you're explaining it internally versus when you have to post things publicly? Do you ever do that?
I don't think most of our customers would know or find it useful. Most of our postmortems are really internally for our kind of large engineering group, and then for all the other, people that care about how the kind of engineers are sorting themselves out. So yes, again, we can assume a level of technical kind of confidence. However, when I'm writing postmortems for networking stuff, I will often get pings back or private replies saying, what's a BGP, and it's then I have to realize, I have to think, okay, I don't need to dumb it down, I need to do more of a story, I need to storify this. I think that's a really good thing. When I'm reading other people's postmortems and it's a story, because I kind of like want to go and get a mug of hot chocolate and read through it and be like, oh yeah, this is great. Oh, classic mistake. That's fun.
Our internal postmortems have definitely shown off the literary prowess of some of our engineers. They've been really fun to read.
Yeah, absolutely. And that also helps with kind of alleviating the stress of them and the ego that comes with writing a postmortem. Or usually the bashing of the ego of going, I made a mistake, or we weren't doing something, ever just so. To turn it into something enjoyable for everyone to read helps everybody, from writer to reviewer.
Yeah, I think having those blameless postmortems are really important because often people will make a mistake and you won't realize it in the moment, perhaps because you're really tired or it's the middle of the night, and it shouldn't, unless there's obviously some kind of gross negligence, which is almost never the case. I think it's really more about the process and how you can improve that. Not trying to blame someone for making a mistake in the time, it's really trying to blame the system and then figuring out how you can improve that system. What you don't want is to have people not admit to the problems that they had just because they're scared of losing their job.
Yes, that's right. That's right. It's I've never come across anyone that has been malicious to machines in my career. And so to keep that stuff light and positive is crucial. But it takes some time for people not accustomed to it to kind of show them how it's done. So I think to write your own postmortems is good. I discover parts of the kind of Yelp internal applications from postmortems. From teams, I kind of think, I've always wondered what those guys do. And suddenly I get a postmortem, I'm like, oh wow, that's really complex, and these people are doing something really interesting. The postmortems allow me to break stuff without actually having to do it.
There's some good example postmortems. If you just Google Heroku or GitHub or Amazon for any of their outages, then they go into a lot of detail, and it goes back to our first point about how likely outages are. It's probably quite likely that a disk is going to fail, but when you consider the complexity of the systems involved and you read how an Amazon whole data center failed, then actually most of these outages are caused by a huge number of things all going wrong and cascading. And it's interesting to understand then how complicated these systems are and the software bugs that might have caused a particular problem that just happened to manifest at this particular point.
Yep. I think we've answered that question of how important postmortems are. Very.
All right, so we've covered all of the topics that we had on the agenda. If anyone has any questions, then you can post them up now. Brian or Charlie, is there anything else you think we should cover or discuss?
I think that's good. It's been enjoyable. If people want to get in contact with me, probably Google isn't the best way, but Twitter maybe, at my handle is YELED, Yelled. Yeah, I look forward to more.
Yeah, I'm David Mytton on Twitter, and you can email david@serverdensity.com.
I'm Trump Card on Twitter, and I admittedly don't tweet very much, but I do check my messages, so happy to get back to anybody.
All right, so this whole Hangout has been recorded, and it will be on the Server Density YouTube channel very shortly afterwards. So I think all that remains is thanks, Brian and Charlie, for joining me.
Thanks for the invite. It's been great.
Thanks for having us, David.
Thanks a lot, then. We'll go on there. Good night, everyone.